Hi, welcome to section 3.1, simplifying expressions. I have the Patriots football game going on in the background, so if you hear any yelling, it has to do with that. So we're going to start talking about how we're going to get to the point where we can simplify an expression. So we have to get some vocabulary out of the way. The first bit of vocabulary is terms. Terms are part of an expression. So let's put an expression down as an example. So if we have 3x plus 6, that is an expression. It is different than an equation. Equation has to have an equal sign in it. So terms are each part of the expression. So in this case, 3x is a term and 6 is a term. Like terms are terms that are raised, that have the same variable and they're raised to the same exponents. So 3x and x are like terms. X squared and 3x squared are like terms. And the same is true of constants. 7 and 3 would also be like terms. So, let's do an example. So we're going to start out with an example. And we're going to identify terms and like terms. So if we have 9x, subtract 2, plus 7, subtract x. The first thing we're going to do is rewrite this problem as an addition problem. So we're going to have 9x, and we're going to add negative 2. So we're going to take the subtraction, and we're going to turn it into adding the opposite. So you have 9x plus the negative 2, plus 7, and then we're going to add the opposite for negative x. So this is now all addition. So we're going to rewrite it as an addition problem. Okay, so terms in this case are 9x, negative 2, because that's a term, so it's everything that appears between the operations of the addition. Negative 2, 7, and negative x are all terms. Like terms are terms that are alike, that are raised to the same power. So 9x and negative x are like terms, and negative 2 and 7 are like terms. Eventually, when we get to simplifying expressions, these are the things that can be combined. So that is an example 1. Oops. All right, let's try another example. All right, so let's try another example. So this is a squared plus 5a, subtract 3a squared, add a. So we're going to rewrite it as an addition problem. So we're adding the opposite. So we end up with adding negative 3a to the second power. All right, terms. A squared, 5a, negative 3a squared, and a are all like terms. Are all terms. Like terms are a squared, negative 3a squared. Those are like terms. 5a and a are also like terms. And there's no constants, so they're not in there. Okay, let's try a couple of these on your own. So why don't you try let's see, let's clear this. Why don't you try on your own to find terms and like terms for y plus 10, subtract 3y. Try that one and this one. 2r squared plus 7r, subtract, that's a subtraction, subtract r squared, subtract 9. Okay, pause the video and go see if you can try those on your own. Welcome back. So now let's see what you got. So let's rewrite this as an addition problem. Y plus 10 plus a negative 3y. And our terms are y, 10, and negative 3y. Those are all terms. Like terms are y and negative 3y. 10 is a constant, and he goes all by himself. He doesn't have any friends. He's all by himself. In this expression, we're going to rewrite it again as a addition problem. Oops. Add the opposite. Terms are 2r squared, 7r, r squared, and negative 9. Oops, don't forget the negative here in front of the r squared. Okay, like terms, 2r squared and negative r squared are like terms because the variable is r and they're squared. 7r is by himself because there's no other terms that are just r with to the 1th power. And then negative 9 is a constant, and that one is also by itself because it doesn't have any, is the only constant in the expression. Okay, so that's how you identify like terms and terms in an expression.